Today we're going to look at section 5.3. This section is going to have us identify the pairs of angles formed by a transversal cutting parallel lines, and we're going to apply theorems about parallel lines. So let's define what it means to be parallel. Parallel lines are lines that do not intersect. Okay, so if they don't intersect, that means they will never touch. So if I was to sketch a picture, let me call this line A. So then I need a line that is never going to go through it. So that's line B. So essentially they have the same slope. They're increasing or decreasing at the same rate. So if you're looking at a picture of two lines, to know that they are not going to intersect, they have to have some kind of marking on those lines. So it's essentially going to be some kind of arrow. Maybe it'll be one arrow, maybe it'll be two arrows, but they have to have some kind of arrow on that line, and that tells me that those two will never intersect. They are parallel. So then if I want to identify the notation for parallel, just like remember we have like a notation for perpendicular. So parallel, we would say A, and then I'm going to have like two little lines that aren't going to touch. That means parallel to B. So A is parallel to B. All right, so now let's start talking about all of those vocab words that we mentioned yesterday, and let's talk about them in regards to parallel lines. So we have something called the corresponding angles postulate. It says if two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, so if two parallel lines are cut by a transversal, then corresponding angles are congruent. Now, understanding this if-then sentence is going to be crucial because a lot of what we're going to be asking you to do is kind of justifying your reason. And so you're going to be writing these if-then sentences, but we're going to be able to actually shorten it with some notation. So let me show you how this notation would be, so then you don't have to write this whole entire sentence. Instead, the fact that we're starting with parallel lines, because it's with the if part, and if you look at the picture, notice that, hey, those two arrow markings right there tell me that the line M and N are parallel. So I would say parallel lines, okay, that's going to start. And then we'll have this arrow that indicates the then part of our sentence. So the part before the arrow is the if part. So here's my parallel lines. The arrow indicates the then part. And we're talking about corresponding angles are congruent. Okay, so what I have notated here, that's what you're going to write when we start justifying all these different things. So if I'm looking at this picture, notice that T is my transversal. It's intersecting M and N. N are parallel because they have those markings. So there's 8 different angles. Remember, corresponding means that it's the angles that are on the same side of the transversal, but one is interior and one is exterior. So before we've identified, okay, that's angle 1 and angle 5. Angle 1 is exterior, angle 5 is interior. They're on the same side, they're to the left. But now that we know that we have parallel lines, I can say that angle 1 is congruent to angle 5. Those are the same. So then same idea on the left side, 3 is interior, 7 is exterior. They are corresponding, and we were just told that if you have parallel lines, corresponding angles are congruent, so 3 and 7 are congruent angles. So then if I look at the right side of the transversal, 2 and 6 are corresponding, so because I have those parallel lines, I know that angle 2 and angle 6 are congruent. And then the same idea, angle 4 is the interior angle, angle 8 is the exterior. They are both on the right side. Those are congruent because I have parallel lines and corresponding angles are congruent. So now let's talk about alternate interior angles theorem. It says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So remember, we're going to be using this if-then sentence to justify things, but we can shorten it up using notation. So we're starting with parallel lines because that was the if part. We'll put our arrow to indicate that now I'm writing the then part, and we're talking about alternate interior angles are congruent. So remember, alternate interior means that they're angles that are inside. Now, in this case, they're inside the parallel lines. So that would be 3, 4, 5, and 6. But if they're alternate, that means they're on opposite sides of the transversal, not supplementary to each other. So that looks like angle 3 and angle 6 in this picture. But because of our theorem, I know that those would then have to be congruent. So then 4 and 5 are alternate interior angles. And once again, because I have those parallel lines, I know that they are then congruent. Then we have alternate exterior angles theorem. So it says if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So notice that in my if part, we're starting with parallel lines. So that's why I'm going to be, with notation, having to write parallel lines first. The then part is talking about alternate exterior angles that are congruent. So if we're looking at our picture, M and N are parallel because it's marked. Exterior angles would be 1, 2, 7, and 8. Alternate means they're on opposite sides of the transversal. So based off of our theorem, because I have those parallel lines, they're congruent angles. Angle 1 is to the left, angle 8 is to the right. They're both outside. They are congruent to each other. So that would mean angle 2 and angle 7 are my other pair of alternate exterior angles, and based off of our theorem, they would be congruent. All right, so we've talked about 3 different postulates and theorems dealing with if I have parallel lines, then there are different types of angles that are congruent. So if I'm looking at this picture, it says if parallel lines are cut by a transversal and one angle is 45 degrees, we're going to find all the other angles, and then we're going to talk about the fact that there's actually 2 relationships between these angles. So notice that the markings right here are what's telling me that I have parallel lines. And so if I have parallel lines, then we talked about the fact that corresponding angles are congruent. So since 45 degrees is up on the right, then inside, because that was outside, then inside over here, that would have to be 45 degrees. So those are corresponding angles are congruent. Remember, we talked about then alternate interior angles being congruent. So 45 that I just wrote is an interior angle. On the other side of the transversal up at the top, that has to be 45. And also it makes sense. Notice that these angles right here are vertical, and vertical angles are congruent. So then down here, this would have to be 45 because several different reasons, one of them being vertical angles right here, or technically these 2 angles are once again corresponding. So there are some 45-degree angles. But we also had to figure out all the other angles. Remember, there is a relationship between the 2 angles that are right next to each other because they're forming a straight angle. Remember, they are supplementary. And so if we're talking about supplementary angles, we know that they add up to 180. So subtract 45 from 180, and this is 135 degrees. So then we have corresponding angles. If that is outside on the left, then I want the angle inside on the left as well. So those are both 135 because parallel lines, then corresponding angles are congruent. Okay, I technically then have alternate interior angles where if the bottom left angle was 135, then the top right on the inside is 135. We then have this angle over here being 135 because once again, we do technically have vertical angles down there at the bottom. Okay, so I filled in all of the angles, and so it says, what are the 2 different relationships? Well, one of the relationships is that we have congruent angles. And that's how we started with all of the 45 degrees. We talked about, okay, corresponding angles are congruent, alternate interior angles are congruent, technically alternate exterior angles are congruent. But then we also have a relationship of supplementary angles. That's how we got the 135, because we've got two angles that are right next to each other forming a straight angle, so they're supplementary. All right, so that brings us to two more theorems. We've got same side interior angles theorem. It says if two parallel lines are cut by a transversal, then same side interior angles are supplementary. So once again, we can abbreviate this. We're starting with parallel lines. So parallel lines. Then now we're talking about same side interior angles, but notice that no longer are we saying congruent. This time they are supplementary. So I would say same side interior angles are supplementary. Okay, so they're going to add to 180. So notice that in this picture, I've got 4 different interior angles. 3 and 5 are on the same side. So I'm not saying angle 3 is congruent to 5. I'm saying angle 3 is supplementary to angle 5. And then 4 and 6, they are same side interior. So angle 4 is supplementary to angle 6. And if I actually go back to the last problem, notice that, hey, these two angles are same side interior. One is 135, one is 45. They add up to 180. They're supplementary. Okay, so here's our last theorem, same side exterior angles. So if two parallel lines are cut by a transversal, then same side exterior angles are supplementary. All right, so parallel lines starts us off. And then we have same side exterior angles are supplementary. Okay, so looking at our picture, we've got M and N are parallel. Notice that 1 and 2 are exterior, so are 7 and 8. But same side exterior means that angle 1 is supplementary to angle 7. And then angle 2 is supplementary to angle 8. So same side interior or same side exterior, those angles are supplementary. So let's start looking at some problems. It says find the measure of each angle indicated and state the theorem between the angles. So notice that in part A, I have my parallel lines because of those markings. We are given one angle to be 130 degrees. The angle that I want is what's questioned here. Well, notice 130 is on the left of the transversal and it's exterior. The angle that I want is inside and it's also on the left. So both of these are same side, but with one being exterior and one being interior, they are corresponding. And so remember, when I have parallel lines, I know that corresponding angles are congruent. So if that angle is 130, so is this angle. In part B, we have our parallel lines based off our marks. Notice that I'm giving us a 65-degree angle. The angle in question is the question mark. Notice how these are both interior angles and they are on the same side. So when I have parallel lines, I know that same side interior angles are supplementary. So these are not congruent, they are supplementary. So to find my angle, I'm taking 65 away from 180. And so this is on a 115-degree angle. All right, so with these problems, we want to solve for x. So notice that we've got parallel lines in part A. So I need to know what the relationship is of the two angles that are given. Notice that 14x plus 2 is an exterior angle, same as -5 plus 15x. They are exterior angles, they are alternate, and so because I have parallel lines, remember, with parallel lines, I know that alternate exterior angles are congruent. So congruent means equals. To solve for x, I'm going to take 14x plus 2 and set it equal to -5 plus 15x. So I want to start solving for x. I'm going to subtract 14x over to the right. That gives me now just 2 equaling -5, and then that'll be just 1x. So the last step to get x by itself is to move the -5. The opposite of that would be to add it. So it looks like x equals 7. In part B, we've got our parallel lines. Notice that the two angles that I have are interior and they're on the same side. So when I have parallel lines, I know that same side interior angles are supplementary. So supplementary means that I add them up and I set it equal to 180. So 45 plus 17x minus 1 equals 180. So I've got some like terms on the left. 45 minus 1 means we'll have 44 plus 17x equals 180. I'm going to subtract the 44 over to the other side. So 180 minus 44 is going to give us 136. I'll divide both sides by 17. The problem is asking for us to just solve for x. So we get x to be 8, and that's all I wanted. So x equals 8 is my answer. All right, in the next one, it says that if line C is parallel to line D, and notice that I even have it marked in my picture, but I didn't necessarily have to have it marked if I'm giving you this information, okay? But if those are parallel lines, we want to find the measure of angle 1. So this angle right here is my angle in question. Notice that the two angles that I have expressions for are the 3x plus 5 and the 2x plus 10. Those are both inside of the parallel lines. So they are interior. They are on opposite sides. That means that when I have parallel lines, I know that alternate interior angles are congruent. So I want to set those two expressions equal to each other. So 3x plus 5 is going to equal 2x plus 10. I'm going to subtract the 2x over to the other side. That will give me just 1x plus 5 to equal 10. I'll subtract 5 from both sides, and so x equals 5. That is not my final answer. I want the measure of angle 1. So notice that there's actually several different ways for us to find angle 1. One thing that I can look at is the fact that there's a relationship between angle 1 and 3x plus 5. They are vertical angles, and vertical angles are congruent. So I could do that. The measure of angle 1 is the same thing as me taking that expression 3x plus 5 and substituting in the 5. Well, 3 times 5 is 15. 15 plus 5 tells us that it's a 20-degree angle. Okay, the other way that I could have looked at it is the fact that angle 1 and this 2x plus 10, those are actually corresponding angles. One is exterior, 2x plus 10 is interior, they're on the same side. So that means that with parallel lines, those are congruent. So I could have actually substituted that 5 into the 2x plus 10, and I would have also gotten my 20 degrees. So either way, two different ways to get the same answer. So that's us identifying the pairs of angles formed by a transversal cutting parallel lines and applying theorems about these parallel lines.